Hi, I'm Mr. Parker and this is question 6 on the OCR Core 2 paper from January 2012. A sequence U1, U2, U3 and so on is defined by UN equals 85 minus 5n for n is greater than or equal to 1. In part 1 we need to write down the values of U1, U2 and U3. In part 2 we need to find the sum between n is 1 and 20 of UN. And in part 3, given that U1, U5 and UP are respectively the first, second and third terms of a geometric progression, find the value of P. And in part 4, we need to find the sum to infinity of the geometric progression in part 3. Starting with part 1 then, we need to write down the values of U1, U2 and U3. All we need to do is substitute in 1, 2 and 3 into our formula for UN. So for the first one we get 85 minus 5 lots of 1. And that's going to give us 80. For U2 we get 85 minus 5 lots of 2 and that gives us 75. For U3 we get 85 minus 5 lots of 3 and that gives us 70. Notice that the terms in this sequence form an arithmetic progression, and that's because it goes down by a common difference each time. So it's got a first term of 80 and it goes down by 5 to 75, and that means that the common difference we would say is negative 5. So in part 2 we need to find the sum between n is 1 and 20 of UN. We can use the formula for the sum of an arithmetic sequence given in the formula book as shown in this box here. So we're trying to find the sum to 20. As there are 20 terms, that means n is going to be 20, and the first term, as we said earlier, is 80 and the common difference d is negative 5. All we've got to do is substitute these numbers into the formula. So the sum of the first 20 terms is a half of n, a half of 20, multiplied by, in a bracket, 2a, that's 2 lots of 80, plus n minus 1d. Well, if n is 20, we can just work that out. 20 minus 1, that gives us 19, multiplied by the value of d, which is minus 5. If we put that into our calculator, we get 650. In part 3, it says given that U1, U5 and UP are respectively the first, second and third terms of a geometric progression, find the value of P. I'm going to start by writing down the first 5 terms of the arithmetic progression that we considered in parts 1 and 2. We already worked out the first 3 were 80, 75 and 70, and we can quite easily subtract another 5 and then another 5 again and get 65 and 60. So now we'll compare our arithmetic progression with what we know about our geometric progression. So in a geometric progression, we've got a formula for the nth term, and that's given here. We're going to use that later on. And we know the first term, which I'm going to call V1 to differentiate it from this sequence up here. It's the same as the first term in our arithmetic progression. And U1 is 80, so we can say V1 is also 80. So that tells us that A, our first term in the geometric progression, is 80. The second term in our geometric progression, it says is equal to U5, which is the fifth term in our arithmetic progression. And the fifth term in our arithmetic progression was 60. So we can say V2 equals 60. For a geometric progression, to get from one term to the next, you multiply by the common ratio R. So if we know the first term and the second term, to get from the first term to the second term, we must have to multiply by some value R. So I can say that 60 equals 80 multiplied by R. Dividing through by 80, 60 divided by 80 is going to give me R equals 0.75 or 3/4. Now that I know R, I can think about the third term of my geometric progression. To get the third term, I can use the formula up here for a geometric progression, and it says that to get term n, you do a multiplied by r to the power n minus 1. So in our case, if we're trying to find V3, we're going to put a in as normal, that's 80, and r will be 0.75, and n minus 1, because n is 3, that's just going to be r squared. Putting that into your calculator would give you 45. So by finding the third term in our geometric progression up here, we have actually found the value of UP, which means we can go back to our arithmetic progression and say we know the first term is 80, we know the common difference is negative 5, and we know term UP equals 45. And if we use the formula from the formula book for the nth term of an arithmetic progression here, we will be able to find out what P is. So in this case, the nth term is a plus n minus 1d. If we apply this formula to the pth term, we know UP is 45, we know a is 80, n in this case is going to become p, so we get p minus 1, and d is minus 5, so we get minus 5 lots of p minus 1. Leaving the 45 on the left, expanding the brackets on the right would give us negative 5p, and then we'd have negative 5 times negative 1, we'd be adding 5, which would give us 85 in total, minus 5p. Adding 5p to both sides and subtracting 45 gives us 5p equals 40. And then if we divide through by 5, we get p equals 8. In part 4, we need to find the sum to infinity of the geometric progression in part 3. Well, from part 3, we know that a was 80, that's the first term, and we knew the common ratio was 0.75. In the formula book, you're given the sum to infinity for a geometric progression, and it's a over 1 minus r, provided that the absolute value of r is less than 1. All we've got to do is substitute values into this formula, so we get the sum to infinity is 80 divided by 1 minus r, so 1 minus 0.75. That's really 80 divided by 0.25, which you could probably do in your head is 320.